The next experiment is integrator and a differentiator. The aim of the experiment is to design and construct the integrator as well as differentiator circuit using either multisim or piecewise software. Okay, the apparatus required here, if we use the hardware, we need function generator to give the input waveform and CRO to get the output waveform, and the components here are used as capacitance, resistance, and breadboard. Okay, first of all we are going to see about the theory. What is differentiator? Differentiator is nothing but which differentiate the input signal, and it allows the particular range of frequencies. For example, we can see that it allows certain high frequency component and block the lower frequency component. If the time constant is very low, it acts as a differentiator. Okay, it produce if in the circuit the input is a continuous pulse with high as well as low value. We can give, see, for differentiator, it differentiate the input signal, allow the high frequency, block the low frequency, and the time constant is also low. For the integrator, it is also called as low pass filter. The time constant is very large. It will allow the low frequency and block the high frequency component. Okay, we can connect the components as per the circuit diagram using the multisim or either PSpice software, and we can obtain the output waveform. Since this is the integrated circuit, it consists of resistance in series and capacitance in parallel. We give the input using the function generator and see the output at the CRO, and this is the model graph. If we give square wave as an input, we will get the spike wave. We will get the triangular wave at the output. Similarly, this is for the integrator and a differentiator. We can also see the circuit diagram for the differentiator, and we can see the output for the differentiator. Okay, in this live. See, this is the circuit diagram for integrator as well as differentiator. This is the circuit diagram for integrator as well as differentiator. Both are given in the same diagram. Here we have given an input waveform as a square waveform, and it is given for both the integrator as well as differentiator circuit. We have already seen that in the integrated circuit, the circuit diagram consists of series resistance and parallel capacitance. Okay, therefore in the above diagram we can see that integrator consists of series resistance and parallel parallel capacitance. So this is an integrator circuit. Okay, here we are given as an output in this particular node which indicates a blue color. Therefore, for the square wave input, it produces the it produces the waveform similar to the triangular waveform. Okay, it is just similar to the triangular waveform. There is rising and falling. Okay, if the same square wave is given to the differentiator circuit, this is a differentiator circuit which consists of capacitance as well as resistance. Capacitance is connected series and resistance is connected in parallel. Here we have taken output at this particular terminal, which is indicated using the red color, and for the same we are giving a square wave input and it produces the spike output. See, this is the spike output. Okay, it is clear that the integrator produces the triangular wave for the square wave input, and the differentiator will produce the spike for the square wave input. This is the integrator circuit and this is the differentiator circuit. We can see the same output while we simulate. See, this green color is the square wave input and this blue color is the integrator output, and this red color spike is the differentiator output. This rising as well as falling edge varies when we change the value of R and C. Okay, thank you.